I don't know. Hi, Libby. This is section 4.2. I'm going to preface this with that we are going to be writing stuff down on that blue sheet. The theorems and postulates sheet. Mine doesn't look blue, but when I like take a picture of it, it kind of turns it white. So this is your blue sheet. We're going to add some stuff to that blue sheet here in just a minute, okay? So this is chapter 4. 4.1, we didn't have any proofs at all, but today we're going to have a little bit of proofs. And they're not, I just told the other kids in here, Libby, that chapter 4's proofs are not as hard as chapter 2's proofs, okay? Chapter 4's proofs, we have a set system of things that you're looking for and that type of thing. They're not really terrible, okay? We'll get to that. All right, so we're talking about congruent triangles to start with. That's what this chapter is, and let's review that congruent. The symbol for congruent is an equal sign with a little squiggly over top of it. And things that are congruent are the same shape, same size. Same shape, same size. Okay? If they are, I'm going to go over here, if they are the same shape but different size, they are similar figures. Do you know what the symbol is for similar? No. It's just the squiggly. It's not equal to. It's just the squiggly mark. Okay, so that tells me that those two things are similar to each other, whatever. Okay. Now we're going to be focusing on triangles as far as proofs go, but these are obviously not triangles. Like the one side looks like a little fish. Okay, so they're just showing you like figures in general, aside from triangles. These are congruent. What we've done is we've either reflected him, rotated him, translated him, like the stuff that we did in chapter 3, and that makes him remain congruent, same shape, same size, versus this guy is not congruent because he is small, medium, large. All of those things are different shapes, different size, right? Okay, so that's that. Not congruent, okay? All right, definition of congruent polygons, okay? All right. We're going to write that thing down on your theorem and postulate sheet. And even though it's not a theorem, we're going to write it down because you're going to use this. So definition of congruent. I'll write out the word congruent. Congruent polygons. I'm going to say definition of congruent polys. Okay. All right. Here's the example. Okay. So it will say if all angles, I'm going to say match up, and all sides match up, the two figures are congruent. Okay, so I have all of the angles are congruent to all of the angles on the second figure. All of the sides on one figure are congruent to all the sides on the other figure. Then they are congruent. Okay. There's not really I'm not going to draw a picture with that, but that's definition of congruent polygons. Okay. All right. Let's go back to the box here where it says that. Okay. And so if we're working with triangles, for triangles, we would have 3 angles over on the one side are congruent to the other 3 angles. And the 3 sides over here are congruent to the 3 sides over here. And if we are able to say that that is true, then the 2 figures are congruent. So we need 6 things. We need 3 angles, 3 sides. 6 things to show that those 2 things are congruent. We have to say all 6 things match up from one figure to the second figure, okay? Which is kind of a pain in the butt. Tomorrow, we learn shortcuts, okay? Where you only have to do 3 things, but we'll get to that, okay? So we have to start with and doing all 6 things, okay? So if I'm trying to prove that these 2 triangles are congruent to each other, I have to first check off all the angles, okay? Can I zoom in on the other side? Check off all the angles. So they start with angle A. They say angle A is congruent to angle H. They use the symbol. So A is matching up with H. From the figure, how do you know that A matches up with H? It has the same number of swoops, right? Same number of like tick marks, basically. A matches up with H, B matches up with J, C matches up with K, because they have the same number of tick marks, okay? So they have those listed off over here. A and H, B and J, C and K. Angles, done. Okay, next. Sides, we're matching the sides up. Okay, so notice their notation. They have AB, side AB is congruent to side HJ, yeah? AB, HJ. How do you know that AB, this side, is the same as HJ, this side? Because this is the same number of tick marks. And they match all of those three up. And as soon as they have all three of those matched up, we check. And we say that these 6 things are all taking place. And as soon as we have all 6 of those things taking place, we write out a congruence statement. Circle that, put a box around that, something like that. They will ask for something called a congruence statement, okay? And when we write out a congruent statement, we say triangle this thing is congruent to triangle this thing, okay? And what you want to make sure that happens is that you put them in order. So A matches up with H, B matches up with J, C matches up with K. And they have to go in that order, okay? Now, if you choose to write it out, let's say as angle or as triangle BAC. Let's say instead you go BAC. That is fine, but if you write it out as BAC, what order does these have to go in? JHK, right? Okay, so it doesn't matter what order they go in to begin with, but the second one has to match the first one. Does that make sense? Okay, so like here, they have valid statements. They're going in order versus these, like C actually goes with J. No, wait. C goes with K. Oh. C goes with K. So they have the third one here is matching up with the second one there. That's not the correct order. So you just have to make sure that the order is correct, okay? All right, let's go down to this guy. They say show that the polygons are congruent by identifying all the congruent corresponding parts. That means we have to do all of the angles corresponding and all of the sides corresponding, okay? And then we're going to write over here a congruence statement. Okay, we'll write a congruent statement here in a second, but we're going to do all the angles, all the sides. Okay. Now, this is a 4-sided figure, not just a triangle. So we have 4 angles matching 4 angles and 4 sides matching 4 sides. Okay, so let's start with the angles, and here's how I do this. I just go around the top one in a circle. So let's start with angle P is matching something. Angle Q is matching something. My squigglies are really ucky. Angle R is matching something, and angle S is matching something. Okay, so we're saying P goes with something, Q goes with something, R goes with something, S goes with something. All right, which one does P go with? G. You can see that from the diagram. They each have 1 tick mark. So P and G go together. Q goes with F. R goes with E. And S goes with D. Okay. All right. So now we go to the sides. Okay. So for sides, I'm going to start with side PQ because that has 1 tick mark right here. So PQ is that guy. Okay. And then let's write out all of our sides. So PQ is the first side. If we keep going around in a circle, we have QR is the next side. What's the next side? RS. And then SP. I just go around in a circle. Okay. There's how that works. All right. Okay, now, when you're labeling sides, make sure you do those in order as well, because PQ goes with this side right here, but do we call him GF or do we call him FG? GF, because we said P first, so we have to say G first. Does that make sense? GF is the first one, okay? QR is going to go with EF. No, it should go with FE. FE, right? Okay, now stop before you do the second one, or before you do the next one. Okay, I'm going to show you how you can cheat. Ready? Okay, RS is the next one that we're doing. Since we already have the angles written out, RS would go with ED. Does that make sense? So we can cheat by using that. We don't even have to look at the diagram, right? Okay, SP would go DG. SP. DG. SP would go DG. Yeah? Does that make sense? Okay, now we've checked off all the angles. Whoop. Checked off all the angles. Check the angles, check the sides. Now we can write out a congruence statement. So we just say this guy is congruent to this guy, and we can just go in order. Okay? So if you want to look at the way that we've written out the angles here, when we're doing a triangle, we would say triangle something and triangle something, but since this is a polygon, since it has 4, we don't have to put the triangle in front of it. We can just name them. So we would say just like P, Q, R, S. We could have gone backwards. We could have gone R, S, Q, P. Doesn't matter. Whatever. We just have to make sure that they line up. So if we go P, Q, R, S, we would have to go G, F, E, D. Yep. That's a congruence statement. We're stating that those are the way that it goes in that order. Okay? Good? All right, example 2. In the diagram, it says ABC is congruent to DFE. Now, a lot of people bypass that, but this is really super important. Okay, this is important information because, yeah, it says that those things are congruent, but also from that statement, I can tell which ones are congruent to which ones, right? Because sometimes in the diagram, you can't really tell which ones go together. This one you might be able to, but sometimes you can't tell. So A goes with D, right? B goes with F, C goes with E in that order. So that statement is actually pretty important because it tells me which ones go together. Okay, so going over here to the diagram, they're having us solve for some things. So we know that A and D go together. Okay, so if A is 45, then D is 45. Okay, great. Then we know that B goes with F. So B is 99, so F is 99. Well, I can use that to solve for Y, right? We know that 8y minus 5 has to be equal to 99. Okay, then we just do the math. Let's add the 5 over. 8y equals like 104. And then if we divide by 8, 10 divided by 8 is 1 with 2 left over, and that's 24. 24 divided by 8 is 3, so y is 13. Does that make sense? Yeah? Okay. All right, now we have to solve for x, okay? So then this C has to go with E, so this would be 36 degrees also. 2y plus x is referring to this side right here, okay? What's this side going to be? 38.4. We get that from the top diagram. So this is the same as this, okay? So we would say 2y plus x equals 38.4. But how do you solve x and y at the same time?
Well,
we already solved y. We know that y is 13, right? So we plug 13 in. This is 26 plus x equals 38.4. And then we subtract the 26. So x is 12.4. Perfect. Okay, and then we have all this solve for the values of x and y. Okay, good? Happy with that? All right, so let's go to the back side, and we are going to write something down. This is called the third angles theorem. We're going to write this down on our blue sheet. So I'll kind of explain it as we go through there. It's theorem 4.3. So this guy has a name, theorem 4.3. It is the third angles theorem. Okay, the third angles theorem. Okay, I'm going to draw a figure here, and I'm going to draw a figure here. Okay, we'll call this guy 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Third angles theorem. Here he is. Okay, so let's say that we know that angle 1 is congruent to angle 4. Meaning that they're the same size, right? Okay, let's say they're both 70 degrees. 70 degrees, 70 degrees. We know that angle 1 is the same as angle 4, whatever. We're saying they're 70 degrees. And we also know that angle 2 is the same as angle 5. Let's say that that's some other stuff that we know. Let's say angle 2 is 50, then that means angle 5 has to be 50. If that is true, then angle 3 has to be the same as angle 6. Is that true? Yeah, angle 3 would be 60, right? And angle 6 would be 60 because it has to add up to be 180, right? So if we know that these two are the same as these two, then the third ones have to be the same by default, right? Like I just know that, okay? That kind of just makes sense, right? Kind of a thing that just like, duh, right? Okay, all right. Okay, good? All right, let's go to, I'm going to skip example 3 and let's write some more things down. Let's go to theorem 4 quick. Okay. Let's do this. Let's do the reflexive symmetric transitive property. This is theorem 4. Okay, we'll use like 2 lines to do this. Theorem 4. Okay, we'll do, I'm going to split this guy in half. And we'll do the reflexive property. We'll do the symmetric property. And we'll do the transitive property. Reflexive symmetric transitive property. Reflexive symmetric transitive property. I'm just going to write these down, and reflexive property is not going to make sense until we do this next proof, and I'll show you what that looks like. Okay. Reflexive property says that, I'm just going to use the example AB, side AB is congruent to side AB. And you're like, well, of course it's the same as itself, right? AB is congruent to AB. You'll see a demonstration of what that looks like here in a second. Okay, so that's going to be that. Okay, AB is congruent to AB. The symmetric property let me see what they have. If they are allowed to do that. Yep. Let's say if you have triangle ABC is congruent to triangle EFG, then by the symmetric property, I'm able to say triangle EFG is congruent to triangle ABC. Like I can just flip those two around and it's the same thing, right? ABC, EFG, EFG, ABC. I can write those two the other direction. Okay, and then the transitive property. Let's go and say if AB is congruent to CD and CD is congruent to EF. This is one we've had before. If those are true, I'll say if in the front of it. If those are true, then AB is congruent to EF. We can like bypass those things. Okay, so those are just all things that we've maybe talked about before. Okay, reflexive property is kind of confusing, but I'll show you what that looks like here in a second. Okay, you will actually use the reflexive property probably the most out of all of these. So put a star by him because you'll use him a lot. Reflexive property. Just put a star by him or circle him, do something. Okay, you'll use him a lot, and I'll show you why. Okay, ready? Good? Okay, let's go. Let's do a proof. We're going to skip example, whatever that last example was. Example 2, example 3, whatever. So this is technically example 4. All right, so here we have, this is a proof. And what we're trying to do is in this diagram, we're trying to prove that this guy is exactly the same shape as this guy, right? Okay, same size, same shape, that they are congruent, okay? Now, just because they're attached like that, do they have to be exactly the same size and same shape? Okay, put this image in your head. So let's pretend like we have something like this. He could actually end up being something like that. Now, that's really exaggerated, right? But just because they're attached that way, they could end up looking like a kite instead. So we're trying to say that this side is exactly the same size and same shape as this side. That's what we're trying to prove. And they're going to give us some information that we know to be true about this thing, okay? And we're going to write each one of those things down. So just because they're attached like that doesn't mean they have to be the same size and same shape. That's what we're trying to prove, okay? So here we go. First proof. This is not too bad. I'll show you kind of how this works, okay? So we're going to write out each one of these pieces, but I'm going to have you put them on separate lines, okay? So we know that DG, or DE, is congruent to GE. Okay, we're going to write that one down. Then we're going to go DF is congruent to GF. I'm just writing out all of that, this given stuff right here on different lines. Angle D is congruent to angle G. And angle DFE is congruent to angle GFE. That guy, and that is all of my given information. They're giving me a lot of stuff. Okay, and again, proof, we're trying to prove that those two guys are the same, and that's going to be my last statement down here at the bottom. Okay, I'm just going to write that down. And triangle DEF, we know that this is going to be my last step. Oh, GEF. This has to be my final step. Okay. And then we've got some stuff in the middle that we've got to write down, and then we'll be done. Okay? So DEF and GEF, we're trying to prove that those are the same. Okay? All right? Okay, so what I'm going to do is I always have you guys, this is the easiest way that I can think of to teach these proofs, okay? So I want you to make like a kind of a third column over here. This is going to be our column of inventory. Okay, this is the easiest way that I can think of to teach proofs, okay? So what we're going to do on the left side is we're going to take inventory of things that we have, like given information that we have, so that way we can look and see like what all we need to have yet in order to be able to prove that these are the same, right? Okay, so we had up above, like the very first thing that we said, to be able to prove that two triangles are congruent, we have to check off all three angles, right? We have to list all three angles, and we have to list all three sides, right? Okay? And we have to have all of those things take place, and then if we're able to say that, then we can say that the triangles are congruent, right? Okay? So we're going to take inventory on the side and say what all we have and what all we need, all right? So let's go through each of these one by one. DE and GE, that's this guy right here. Whoop. DE and GE. DE is this one, GE is this one, okay? We know that those are the same. They've tick marked them for us. That tells me that I have a side. I have two sides that are the same, so I'm going to put a side off to the side, okay? All right, the next one is GF and DF. GF is the same as DF. We know that those two things are the same, and that gives me another side, right? Those two sides are the same, okay? Then I go down to angle G and angle D, and they've marked them off here for me. That gives me an angle, so I'm going to list an angle off to the side, right? Okay, that gives me an angle. And then they say angle DFE. DFE is this bottom one, okay? And he is the same thing as GFE, is this bottom angle. Okay, now, here's my question. Hold on. Why were they able to get away with doing this, naming it with one letter, versus this having to name it with three letters? Do you see that? Okay. Here, when they said D and G, they can name it with one letter. Because if I tell you angle D, there's no question I'm talking about this one, right? If I say angle G, there's no question I'm talking about that one. But if I say angle F, you're like, well, angle F has two angles, right? Which one is it? So when you have a vertex that has more than one angle attached to it, you have to name it with three letters, so I know which one you're talking about. If it has one, you can just get away with naming it one. So E, we have to name it with one or three? Three, because there's three. He has two angles, so you have to name him with three letters, right? Okay, makes sense? All right, so here we go. So that gives me another angle, right? So in our inventory, we have two sides and two angles, and we need three sides and three angles, right? Okay, so let's talk about that third angle here. This angle right here and this angle right here. If this one's the same as this one, and this one's the same as this one, does these two have to be the same as each other? Why? The third angles theorem, right? Okay, we know that if two of them match up by the third angles, I'm going to abbreviate, theorem. By the third angles theorem, we can say that those match up. Okay, so let's name those angles. Angle DEF and angle GEF. DEF and GEF, would those work? Yeah? Okay. And those, that gives me my third angle. So all of my angles are done. I can check him off. Angles are done. Okay, now I have to write the sides. Okay, I have one side that I'm missing, right? I have two sides and then I'm missing a third side. Okay, so let's go back to the diagram. I have one more thing that I need. I need a side, right? Okay, so now looking at this diagram, what side am I missing? The FE, right? Okay, that's this one. That's the one that they share, right? So this is kind of confusing. This guy is side, we'll call it EF. We'll go in order. EF, so they're saying EF for this triangle is the same as EF for this triangle. Well, they're the same length, right? They have to be the same length because it's the same side, right? But that's where we use that reflexive property, right? Haley just said it. Reflexive property, we're talking about EF for the one side is the same as EF for the other side. That's kind of where that reflexive property comes into play. When you have two triangles that are attached to each other, that reflexive property is what you use, right? Okay, so we're going to say EF is congruent to EF, okay, by the reflexive property. Okay, and that gives me my third side. So we have three sides, three angles. We can check off the sides. Boop. Okay, now, given that we have all 6 pieces, are we able to say that those 2 triangles are congruent? Yeah. Yes, by what? By definition of congruent polygons. That's what we wrote down on that theorem sheet, the first thing that we wrote down. By definition of congruent polygons, if all 6 things match up, they are congruent. Okay? Not too bad, right? It helps if you take inventory off to the side because you know what you have and what you need, right?
I forgot what my thingy was.
You forgot what your thingy was. Oh, what your little symbol is.
Oh my gosh,
okay.
when I was at Disney World in the aerial little exhibit thing, that's how she had it signed.
Really? Nice. Very nice.
The aerial thing with
Very nice. Okay, so I'm gonna explain this to Libby. You guys have this paper, so you can write these down. Okay, so on 4-2 skills practice, you can skip number 2 because this is listing all the stuff out, so you can cross off number 2. I think Libby already has these crossed off for her. So you can cross off number 2, and then number 5 is a proof, but it's very, 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 very similar to the one that we did on the notes. Like same procedure, everything. It's pretty easy, okay? So look at what you have, look at what you need, take inventory of everything. So it's very similar, okay? If you go to the back side, you can skip 1 and 5, okay? So I won't make you do the proof on number 5, but do 2, 3, 4, and 6. 6 is just asking you questions, so it's not a proof. 6 is just asking questions. It's not terribly difficult, okay? All right, good? Happy with that? All right, that's all I have. Goodbye, Libby.